Hi guys and welcome to my channel. This video my topic is integration, or sometimes it's called anti-differentiation because it's really the opposite of differentiation. It's done in Form 4, Form 5 and it's really covered in Add Math. Now of course it goes on in Pure Math, but in this video I'm only going to cover the topics that are relative to a Form 4, Form 5 student. So please stay tuned to see what I have in store. Now, integration really has two parts. It could either be definite integration or indefinite integration. Definite integration is where you have the integral sign and you have values on top here, like it could be like 10 and 2 and so on. The value at the bottom here is always smaller than the value at the top. We sometimes call these limits. Indefinite integration is where we have the integral sign without values at the top here, right, or bottom. Now, whether it be definite integration or indefinite integration, these are some rules that would apply. Now remember, there are more rules than this, but I'm only covering those for the Form 4 and Form 5 students in Add Maths, right? So the basic rule is this one. If you're integrating x to the n, then it'll be x raised to the power of n plus 1 divided by n plus 1, and we always add on a plus c. Now this plus c comes about because, say we had to differentiate y is equal to 3x plus 7, right? Well then that will simply mean you're writing divide the x is equal to 3, right? Now this 7 became a 0. Now if I were to integrate this equation here, then I will get this. The integral of 3 with respect to the x will end up being 3 with an x, and then I will always add on a plus c. So I'll get 3x plus c. Now this plus c caters for if there were any constants. Now we know in our sum there was a constant. It was a plus 7 and became a 0, right? In differentiation, please don't get it mixed up. This here is differentiation, which is the opposite of integration, and this here is integration, right? Now I was trying to show you the connection between the two and the reason why we have put on a plus c. That reason is really just to cater for any constants that were there in the equation that we were before. Now in some cases we can figure out the plus c, the value of the c that is, and in some cases we cannot. We just leave it with that, right? So now let me go to my next rule. The second rule is here. It says the integral of ax plus b all raised to the power of n dx is this, right? Now I'll be doing a couple of examples on this as well. And then lastly, the integral of cos u with respect to du would be sine u plus c, and the integral of sine u with respect to du is minus cos u plus c. Now this is the opposite like of what it would have been for differentiation, right? So we need to take a note of this. Also, we must note as well that here my equation was with x, so then I have a dx here. Here my equation is a u, so then I have a du here. So whatever you are integrating, you always have to put a d something with respect to the variable that you are integrating. Now before I get into the examples, we just need to remember that for definite integration and indefinite integration, all these rules apply, right? The difference between definite and indefinite is definite has values here and here, right? Whereas indefinite does not have a value. It has nothing at the top, nothing at the bottom, so that's why we put the plus c. So now let me move on to some examples. Example 1, right? In question 1 it says to integrate 4x raised to the power of 5 dx. Now this will definitely be indefinite integration, right? So I'll just follow this rule here. It says that I'm going to write back my 4, I'm going to write back my x, and instead of putting it to the power of 5, I'm going to raise it by 1 because it says n plus 1. So it's going to be 6, and I'm going to divide by that same value here because of that rule. Now, of course, with integration, definite integration as is, we have to put in our plus c. So this, everyone, will be the answer. Now, of course, you can cancel these two. So you can get 2 over 3 x to the 6 plus c, and that is the final answer. Well, 2 now. So say I had to integrate this. 5x all raised to the power of minus 5 on 3. Now we follow the same rule. We write back our 5, we put x. This will now be minus 5 on 3 plus 1, which is the same as well. Since it's on 3, I'll just add 3 on 3. Minus 5 on 3 plus 3 on 3, and we keep working. That will be minus 2 on 3. This piece here now of course we have to add the plus c. We could work it at the side. 5 divided by minus 2 on 3 is the same as this. So I'll write this here, and I'll write x to the minus 2 on 3 plus c, which is the same as saying minus 15 on 2. Let me just write this better here. Minus 15 all on 2 x to the power of 2 on 3 plus c. Right, so I'll write it over here. Now the reason why I took that at the bottom here, because this negative sign here means that the index is really, the value should go as a denominator. So I'll write it over. Minus 5 on 2, and in the denominator here I'm going to put my x, and I'm going to put 2 on 3 plus c. And of course this still means minus 5 on 2 x squared root 3 plus c. So all of these are possible answers. You could go this one, or even this one here. Some people even leave it here like that, but I prefer this answer here. So it's up to you, right? So now let me move on to my next example. Example 3. Now this only looks difficult because the x value here is at the bottom, right? But simply with the rule of indices, I could move that. So I could get x to the minus 2 dx, and this is the same thing. So I just continue. Following the same rule, add in 1 here, so I'll get minus 1 here plus c, which is the same as minus 3. This minus 1 means the x is really at the bottom, and this is my answer. Example 4 now. If we're given a question that looks like this, where we have brackets here and brackets here, the best thing to do is really just multiply out, just simplify. So I'll get multiplied this way. So I'll end up getting the integral of 3x cubed minus 14 all dx, right? Now integrating every possible piece here now, we get this. Now I really hope that you all try these questions as well to make sure that you understand. And now I just simplify. So if there's anything I cancel, it doesn't look so. So I'll just write it back. And all my powers are nice positive powers, so I don't need to bring down anything. So this, everyone, is the answer. Note, all of these examples that I've done so far have only covered this first rule, right? So now I want to move on to the other rule, which is this rule here, right? Example 5 now has 3x plus 8 all raised to the power of 4. Now, what we can do the same thing like example 4. We could expand, but raising this to the power of 4 will give us a very long line to integrate. So what I recommend is that we use this rule here, and it says if it's ax plus b raised to the power of n, but it must be a linear function, and this is a linear function because the highest power of x is 1, then we could follow this rule. So following this rule, it means that I'm going to write back my equation, my linear equation, 3x plus 8, and instead of writing to the 4, I'm going to put to the 5 because it's n plus 1. Then I'm going to put it at the bottom here to 5, and then I'm going to multiply by a, which is the differential of the inside, 3. Of course, tuck in my plus c. So then I get 15, right? And that's it. That's the answer for number 5. Example 6 now, right? So now we're doing our first question where we have trigs in it. So we have to integrate this. Now we're following the rule. The integral of this piece here will be negative cos of u. So we're going to write back the 5. So we're going to write the 5 here, put the negative, put cos of x, right? And this is a minus 8 here. Now this integral of a cos is a positive sign. So this minus 8 will remain. And we'll put the sign x, and then we put a plus c. So this, everyone, is the answer. This is my first example with definite integration, right? Because we have limits here, right? Upper limit is 2, lower limit is minus 1. So what we're going to do, we're going to ignore these for now, and we're just going to integrate here. Getting x cubed on 3 minus 3x squared on 2 plus 7x. And we're going to place these limits here, 2 and minus 1. Now from this point onwards, what I need to do is I need to substitute, say, 2 into the equation here, here, and here. So that will give me, I hope you all are following. Alright. Then I need to substitute this minus 1 here, here, and here. Just as how I did it with the 2, but I'm going to minus this value. So I'm doing this in green here, so it'll be minus 1 cubed, etc. Right, now you're going to simplify. So I'm going to do it in colors again. Simplifying here, I'll get 8 on 3. Right, simplifying here, I'll get minus a third. This will be squared. That'll be minus 3 on 2 minus 7. Now working this out, now you're going to work out the red and then work out the green and then minus the two answers. We are going to get 10 and 2/3 minus 8 and 5/6, and working this out we get 19 and a half. So this is our answer. So you see, it's different from indefinite integration. With definite integration we get a value, like a number, right? Now this is the same as area under a curve or using volume or so. So now I want to move on to that. Example 8 now is my first example finding the area under a curve. Now what happens here is that, say we have a curve drawn like this line here, right? A curve could go under the x-axis like this and above, right? We know this already. This is the x-axis and this is the y-axis. And say we were asked to find the area under the curve and between the x-axis. So under the curve means, well, the section that is under it, right? But between the x-axis, now it gives us a specific area. So that is actually here. And they say it's from x is 3 and x is 5. So this is 3 here and this is 5 here, right? Now, if you notice, they call it section B and they have it written here as well. Section A is also area under the curve and between the x-axis, but it is below the x-axis. So this area here, if we were asked to find this, would actually be negative, right? Because it's below. But in the CSEC Add Math syllabus, this is not included, right? We don't find areas below the x-axis, right? So I'll only work on finding B, section B. So to find this, if you're given a diagram, all you do is you simply put your integral sign, put your upper limit, which is 5, lower limit, which is 3, and you put your equation of y. Now, in our case, our equation is x by x minus 3. And as I mentioned earlier, the first thing we do is we expand. And then we integrate. Once we have integrated, then we substitute the 5 and the 3 as before. So getting the 5 here, I will get 5 cubed on 3 minus 3 by 5 squared on 2, and then the lower limit, right? And now simplifying these two sections and getting one section, 125 on 3 minus 75 on 2. 27 on 3 minus, that'll be 27 on 2. Now simplifying our final answer, and since it's area, the 8 and 2/3 squared, because it's area, right? So just to recap, when we're finding the area under the curve and, well, under the curve and above the x-axis, right, it's the same as doing definite integration, where we put the upper and lower limits like this and we put the equation of the curve here, right? And we just proceed as normal as we did in the previous example. I would now do one other example on area. Example 9 now. Again, we have find the area bounded by the curve and the x-axis from these coordinates 1 and 3. So we do the same. Put the upper limit, lower limit, the equation of y, and we proceed. Right, now if no diagram is given, you can do a sketch to make sure that your curve is above the x-axis and so on. Right, now substituting these values. Sorry. Alright, that's the value for 3, and then the value for 1 now will be this. 4 by 1. Right. Now working this out, we get 27 on 3, which is the same as 9, plus 9 on 2, plus 12, minus 1 on 3, 1 on 2, plus 4. Simplifying again, 20 and 2/3 units squared. Right? So I hope you all understand this. Now let me move on to volume. Volume now, guys, it's a different formula. So that's why I have something else written here. For volume, we have to write a pi in front. We put the same integral sign. We have the upper limit and the lower limit like this. And instead of writing y like we had before, we are going to take that equation of y and square it. Now, this is very important, and it's a step that a lot of students forget. And once you square that, the equation of y, we should get something in x. So then we integrate with respect to dx. So now, let's look at the first example. It says, determine the volume of the solid obtained by rotating this curve here now from 1 to 4. Now, what happens here when this is rotated about this axis is that this same arrow here that's going like that, this whole curve will go like this. Like this. So it will form like a kind of like the joint of two cones kind of thing. Like this. That's how it will form. So this is the shape that we're actually finding the volume of. Now by applying this formula, we are actually doing all that calculation in one, right? So let me follow with my steps. I will take the equation that I have, which is this, and I have to square that. And it all out, I'll get the volume is equal to pi integral from 4 to 1 of y squared dx, x squared minus 4x plus 5 all squared dx. Now squaring this now, I would get, right, so I just could write it twice, sorry, and then you literally just multiply out. So you can go like this, multiply these values here, and then you multiply this second value here by these three, and then lastly you multiply this one by this here, right? So you'll get three separate sets of values, which will end up being x cubed. Now of course you have to put your pi integral x cubed, going from 4 to 1. Sorry, this will be x to the 4. That's the red section. Blue section. Right, now all of this I have to differentiate with respect to the x. Now I just want to simplify this whole long equation. 4 and 1 are my upper and lower limits. This is the only x4, so I'm just going to write back x4. Then I'm seeing here I have x cubed here, x cubed here. So that looks like it's minus 8x cubed, x squared here, and x squared here. So that's 10 and 16. Now that is just finding the square. So you see how these questions can be long, right? So then I'm going to integrate x5 on 5. This will cancel. Right, and then I'm going to put my 4 on 1 here and substitute. So we do all of that and we put in our 4 and our 1, we will get 78 on 5 pi units cubed, right? So you're supposed to substitute your 4 in each value here, simplify, substitute your 1 in each value here, simplify, and minus the two answers. So this will be our final answer. Of course, we put a cube because it's volume we're dealing with. This takes me to the end of my video. I hope that you all understand what I covered. My topic today was integration. I did definite and indefinite integration, and I covered 10 different examples. So I hope that you understand. Please feel free to like, share, and subscribe. Take care, everyone.